Hey everyone, it's Sophia again. Today I just wanted to go over some observations that I found. There's not really a proof here per se, but I am noticing some patterns that I would like to share with you. So first off, this is just a normal multiplication table. It's 12 by 12. I highlighted the perfect squares. They're along this diagonal. And if we see here, I've got it color coded that every number that shows up in this also shows up in this line. So the perfect squares offer a line of symmetry. I suppose by design, this isn't too big of a deal, but I'd like to go over to a modded out relation table that I found on the next page. So this is just a same kind of table. It's 12 by 12, reduced by modulo 4. And here again, I have the perfect squares highlighted. First, I'd like for us to notice that there's a pattern that goes 1, 0, 1, 0, all the way to 12 by 12. And also, I suppose by design, every multiple of 4 is remainder 0, so therefore every column and row of multiple 4 is also 0. But I think there's something a little spectacular going on. So within each little block of 0, there's like miniature domains. First, let's look at this 4 by 4 really quickly. So we have opposites, 1 and 1, 0's in the middle, 2, and then 3 and 3 are opposites to one another. I'm not exactly sure why this is the case. I thought it had something to do with modulo 4, but I tried it with modulo 2, same kind of thing, it's smaller. There are miniature domains that do appear. One, and then I thought, well, maybe since I did that with modulo 4 and modulo 2, it was isolated to even numbers. So I tried it with modulo 3, and same sort of pattern showed up where the multiples of 3, notice this is no longer a 12 by 12, it's a 6 by 6. The same kind of patterns appear. The multiples of 3 have columns and rows of 0. That's obvious, but the opposite, these miniature domains, opposites are the same. So 2 and 2, 1 and 1. I thought those were pretty cool. Typically when we do these like relation tables in 3200, we only go up to, with modulo n, we only go up to n minus 1, because in this example, modulo 3, it just gives us a row of 0 and a row of 0 and a column of 0, so there's nothing that interesting. But I think when we expand past n minus 1, we can see these really cool like little patterns and miniature domains, and we can do cool color coding. But if you have any references on why this pattern shows up, or if you have any insight, please let me know.